How's it going, everyone? So I thought I would walk through with you two related topics, but also two topics that have different terminologies at the same time. So first, let's start with this figure on the left, and it's talking about the electrical pathways through the heart. So the first thing that I wanted to point out is that if you took any of this cardiac muscle and sort of put it by itself in a petri dish, it would have the ability to create depolarization by itself. And so that's interesting, but the only reason that we start up here at the sinoatrial node or the SA node or the pacemaker is because this has a higher rate of depolarization. And so basically, if you would to put this next to any other part of the heart, it would take over and become the pace setter or the pacemaker. And so that's just why this sinoatrial node, the SA node here, is where we start. And so, okay, so what happens is depolarization begins at the SA node, and it travels down both the right atrium and the left atrium across to the left atrium through that interatrial pathway, down to what is called the atrioventricular node, past the atrioventricular bundle or the bundle of His, and then down into these right and left bundle branches, down into the Purkinje fibers. Okay, and so as the contraction is happening, the contraction of your left and right atrium, blood is flowing down into the ventricles, and then the ventricles start to contract down here at the bottom, at the base, and sort of push up like this. So the blood flows down into the ventricles and then pushes up into both of the aorta and to the pulmonary arteries, the right and left pulmonary arteries. And so that's how the electrical signaling works. Now let's talk about how the blood flows. So blood flows back in to your right atrium from both the superior and the inferior vena cava. Now this is deoxygenated blood here. So as the blood flows down from your right atrium into your right ventricle, notice it's happening at the same time on the left. We'll just start with the right. Down from your right atrium into your right ventricle, the blood flows. Notice these valves right here are going to be open all the time, and the blood will flow in. That electrical signal that starts here pushes the blood up. That closes these valves, and that's the lub sound that you hear, and pushes the blood into the right and left pulmonary artery. Now, pulmonary artery takes the blood to your lungs to get oxygen and become oxygenated blood. And then if it's already oxygenated blood, the blood flows back to the heart through your veins. Remember, A for arteries is away and veins comes back. So oxygenated blood comes back into your left atrium, flows down as the contraction comes, flows down into your ventricle, then remember, it starts at the base here, pushes up into your aorta, and then there's three. This goes to your head, this goes to your left and right arms, and then the aorta flows down your body to the rest of your body, below your head, below your heart, and this pushes the oxygenated blood back. And so let's do it one more time. So as the pacemaker sets the contractions of the atrium, the left and the right, this pushes blood down into the ventricles. Then that signal flows all the way down to the base, which then pushes upwards of the ventricles, which then pushes the blood up into the pulmonary artery and the aorta. And so that's how these two basically semi-different things, the electricity and the blood flow, that's how it works together. So if there's any questions on that, just send me a quick email and I'll be sure to get back with you.